This is an interview with Mark Korin, CEO and President of Alpha Systems, a leading manufacturer, patents included, of angle of attack technology. Mark, thank you so much for spending time with myself and Plain Tech. And as you mentioned, you've been doing this for 22 years.
Yeah.
What made you decide to become an angle of attack evangelist?
This is going to sound kind of strange, but I started my flying career in the early 80s flying ultralights. And I've worked as an engineer since early 80s on up. And I've always loved flying, and I was flying about 2,000 feet off the ground. I was flying over houses and trees, and I had a engine failure on an ultralight. And I circled around, and I set up for an approach in someone's backyard, and I overshot the approach. And I did the cardinal sin, is I set up for a 90-degree approach into another backyard, pulled a stick back, kicked the rudder around, and I stalled the aircraft at 100 feet off the ground, burying the engine 2 feet into the ground. You're talking to a guy that should be dead. It took me 10 years to even admit that I did something that stupid. After a month of rehabilitation, I got back up in the air, and I was flying again. So I never stopped. It never stopped my love of flying. But I always felt that, there was something that I was missing in the cockpit. All I had for instruments in the ultralight, because it flies so nice and so slow and so maneuverable, is you flew by the seat of your pants.
Sure.
I had an altimeter and a engine RPM gauge. Everything else was just basically by the seat of your pants. So years went on, and in '96, I was the director of engineering at another company. I quit to start this company. I had an opportunity to buy the patents and design the first electronic bar graph using differential pressure system that was actually created. I found out later it was actually created by the U.S. military in 1955.
Oh, wow.
So in doing a lot of research, I have probably 150 to 200 different articles, patents, writings.
How many patents do you have, Mark?
Personally, right now I have 5, but none of them have to do with AOA.
Oh, okay.
I own actually a company called Depot Star, and Depot Star is the design and engineering company. My background's actually started in the medical field. I worked as a design engineer working on electronics for Medtronic, St. Jude Medical, and those medical type companies. So I built the electronics for the implantable defibrillator and heart valve testing equipment and stuff for St. Jude and all kinds of different medical companies along the way. When I started to look at this differential pressure technology, it's about human factors. It's about how do you get an instrument that's extremely accurate so that a pilot can interpret that information without thinking about it. Okay, adding or subtracting airspeeds, or adding or subtracting weights, or adding or subtracting different things. And I got my pilot's license late in life, so my wife told me, if you're going to keep flying, you better go do it, quote-unquote, legitimately. So I went and got my VFR pilot's license, working on my aerobatics and my IFR.
When were you licensed, Mark?
Geez, I think 2006. I do more flying with customers for calibrations. I've got friends here in the Twin Cities that I go up flying with quite a bit. I had 3 Russian jets for a while, that kind of stuff. I was rebuilding those. I'd be going up flying with friends. And
which Russian jets?
The L-29 Delphin. I had 3 of those. And then I was involved in bringing in 5 L-39s for a while. And we put those together, and I was going to start flying one of those, and we sold them. We imported them to sell them, and then we were going to keep one each, and that relationship fell apart. So
too bad. I have a buddy here in Toronto that has an L-29.
Oh, really?
And a MiG-15. He keeps them at our international airport, and mostly just flies them at air shows and stuff.
I had 3 of them in my garage at home. I'm not on an air park. I bought one that was in a tornado, so that was damaged, and I was using that one for parts to build the other 2.
Your wife must have just loved, you must have a big garage.
Yeah. I've got about a 6,000 square foot shop at home.
Oh, wow.
This angle of attack thing and running an engineering business and being mayor and stuff is just a small part. I love to build stuff. I love to create new inventions and new things.
Cool.
And this angle of attack thing was something, when I started building it, I realized how important it was, not by me, but by the customers that would put it in and say it's changed the way they fly.
When did you get the start on angle of attack technology?
You mean when did I first start working on it?
Yeah.
1996, in fall of 96.
Okay.
Yeah,
Wow.
so I started building in 96. Our first show was 97 at Oshkosh.
So you've been doing this for a real long time.
Yes.
So we could arguably say 22 years.
Yeah, the original product that I designed, which was a 4-inch long bar graph, LED bar graph, 16 LEDs, it worked perfect. It was based on differential pressure. The design of the system, like I said originally, the differential pressure system was used by the military in the early 50s. It was underutilized in general aviation. And what I realized looking through a lot of the data, that even the Wright brothers identified angles for climb, and they had a stick and a protractor and a string, and they could realize at what angle they needed to pull to continue a climb. If they pulled beyond that, they would no longer climb. And that was the first recognition of the importance of angle of attack, was a protractor and a string based on the Wright brothers' findings.
That's very cool. So you developed this 4-inch bar graph.
Yep.
With differential pressure systems worked on by the U.S. military. Then what happened?
Well, then I found a need, or customers were asking me for different shaped products over the years. So we shrunk the product down from a 4-inch bar graph to a 2.5-inch long version with miniature LEDs and a round one that would fit in the panel. And we were still selling at the time a differential pressure gauge, a pneumatic pressure gauge that we would modify and put a carbon fiber shroud around it and all kinds of stuff. And we realized that the key success over the years, the key success to any product is how much they use it, how much do the customers. I mean, anybody can take a rock and sell it as a pet. If you take that pet rock and nobody uses it, it's a cool thing to have on your desk, but nobody likes it, pretty soon the product will end its product cycle. What I found was that the customer's feedback that I listened to was most important, was the ones that would come in and say, "This product is the best thing I've ever put in my airplane." Those are the ones that put it above the glare shield. The ones that put it in the instrument panel next to, quote unquote, the airspeed indicator. I have an opening down where my clock used to be. They never use it. They say it's a neat gadget. Over the years, we were making more and more products in different styles based on LED technology. Then about 5 years ago, I entered a contract with Bendix King. And Bendix King liked our product. We made a legacy product, we called it. It was a military chevron. And throughout the redesign of the product, originally, I looked at the military styling. Why was it that the military indexers were standard in all of the military aircraft? So I went back and researched that and realized that from a human factor standpoint, your eyes and your brain can pick up different shape changes. So they had indexers that were put directly in front of the pilot's view. You had to look directly through it. So we created what was called the legacy instrument. It was a bar graph chevron style that had a chevron pointing down, a chevron pointing up, and a donut. And going back again 10 years ago, I realized that every AOA system, that there was only a couple other people competing, were identifying stalls. Everybody assumes that angle of attack is to just identify a stall. And that's absolutely misusing a technology that could be used in a much more beneficial way to a pilot. So what I did is, again, looking at how the military utilized the indexer styles, is the donut in the military is called on speed. So it was either a chevron pointing down, which intuitively the pilot would push the nose over, going too slow. The donut was on speed, and that's called optimum alpha angle, or the chevron pointing up, which is when you're doing an approach, it's too fast. And it was all based on AOA, angle of attack. Angle of attack is just a way to identify how much lift your wing is producing away from stall. It's that simple. When I did that legacy unit, I transferred that to a product line and I started selling more and more product, and they could put it on we have a swivel kit above the glare shield, and the people just loved it.
How many units have been sold so far?
I'd hate to tell you something that I don't know an accurate number. I would say it's probably under 10,000, maybe 8 total units since 22. We had mechanical gauges, 3 different bar graphs, and then the legacy chevron style. And then I mentioned earlier here that about 5 years ago, now 6, we entered a contract with Bendix King. What we did is we took that older technology and created their egg, their KLR-10. It was based on a colored film technology so that when you illuminate the colored film, it would show up red, blue, yellow, or green in their shape. They asked us to design a product, working with their team, put together a product based on our differential pressure system. Works good. I realized, though, after I finished that product, that I was unhappy with our LED versions. There were more features like stick shaker output, flap input, different flap positions, analog and digital flap input, gear advisory, things like that that were needed, which forced me to go back to the drawing board and redesign all of our product. One of the things I did was I looked at a different technology that we created in-house that we call light pipe technology, which illuminates or fluoresces a film, a white clear film, the color of the LEDs themselves. And then we use a camera lens technology to amplify red, blue, yellow, and green to the human eye. So the new technology after I created the Bendix King product line is far superior now. Now the people look at our product. It is so crisp and so clear. We tell people don't look at it. Look through it. Look around it. Look over the cowling when you get it in your aircraft. And if you can't interpret it instantly without looking at it, then it's not working properly. So now that they put either the unit above the glare shield, we don't even sell one anymore unless you buy a dual unit, that goes in the panel and one above the glare shield. About 3 years ago, I invented the heads-up adapter for our units. It's called the Valkyrie heads-up adapter. It's called a beam splitter glass, same glass material that all the heads-up corporate jet stuff use. We have it custom made for our product, and then we machine and build the holders and everything in-house.
Oh, cool. How many folks are in your company?
I have 35 employees here. Alpha Systems has become a product that we design, build, service, and maintain in-house, along with, we still do a lot of work for companies like UTC Aerospace. We don't make their products. We make test equipment that validate the performance and criteria for their products.
So I noticed that your electronics package has audio panel integration. So what kind of audio alerts do you push out?
Well, right now, we actually just introduced a brand new variable pitch audio tone. It's the 6th audio option. It was given to us by an ex-military fighter pilot that believed that not only do we need a visual representation of how much lift the wing is producing, but an audio version too. So we have 6 options. One is a simple tones, female voice, getting slow, too slow, at certain alpha presets. When you get to a certain point, it'll say getting slow. There's a doorbell chime and then slowing for different presentations. Some people get scared when you hear getting slow when you're 3 miles out. It's all in a matter of what the pilot believes is a better warning, a pre-warning for identification of high alphas. Every aircraft has an alpha range from cruise, which is the lowest angle of attack, to the highest angle of attack, which is stall. What we realized is where angle of attack is most used is from maneuvering alpha angle, or maneuvering speed, weight adjusted, correlates to an angle of attack, to optimum alpha, which we correlate to every pilot operating approach handbook. Every approach in every handbook I've ever seen so far is 1.3 VS, or 1.3 stall. Correlates to the donut in the military styling, or the optimum alpha for perfect approach, is 1.3 VS. So what we do in our system is we have the identifier as 1.3 VS. Once you correlate an airspeed to an angle of attack, then from that day forward, airspeed doesn't mean anything. There's only 4 reasons, by the way, you need airspeed. Do you know what those are?
Go ahead, you tell me.
The FAA tells you have to here in the United States. It's a primary flight instrument today. When to put your gear down, when to put your flaps down, and VNE, never to exceed. But those last 3 are airframe structural limitations to keep your wings on, your flaps on, and your gear on. If I had my way, I'd rip every airspeed indicator out of every airplane because it is so inaccurate. I did a number of seminars across the country here over these years, and I was approached after I did a seminar down in San Jose, California, by 4 FAA officials. And they came up to my booth. You know, anytime a bunch of FAA officials come up to your booth, you get kind of scared. And they came up and they shook my hand and they said, "You got to keep doing what you're doing, but you're missing the bigger picture." And I said, "What?" And he says, "You got to ask everybody 2 simple, basic questions. Do you have an airspeed indicator in your airplane?" he said. And I said, "Well, that's a really dumb question because you as the FAA mandate it to be a primary flight instrument." He said, "Exactly." He said, "Ask him the second question. When was it the last time that you had an airspeed indicator calibrated at 10, 20, 30, 40, 50, all the way up the scale at every location?" He said, "We mandate that an airspeed indicator be in every aircraft, but there's no mandate that it's accurate or tested at every indicated needle position."
Those are good questions to ask.
Yep. You know, the problem is that an airspeed indicator is only accurate in a 1G maneuver. You're a pilot, right?
I am.
Okay. So where do you need an airspeed indicator most accurate? At the low end of the scale, right? Where is it most inaccurate? At the low end of the scale. And it's only accurate in a 1G maneuver. If you're in a 2G maneuver, you need more airspeed to get the same lift potential away from stall. If you're in a 45-degree bank turn, if you're hot, humid day versus a cool day, low humidity, the airspeeds change, but the angle of attack at which you would stall or the angle of attack at optimum alpha would be identical from aircraft to aircraft or from flight to flight, but the airspeeds will vary based on a number of conditions. And that's what's so frustrating to me as an engineer. You've got an instrument that is so inaccurate, and the simplicity of our differential pressure system measuring the margin of lift away from stall, how much lift, having too much lift can be as dangerous as not enough.
So from an installation perspective, you mentioned there's a little bit of programming that's required in your electronics package?
Right. The electronics part of it that has the computer and the differential pressure system and all that is called the display interface module. We have 2 different versions now, one for pressurized aircraft and one for a non-pressurized aircraft. In the non-pressurized system, everything is one box. In a pressurized aircraft, in the States here, and I'm sure Air Transport Canada has got an issue with people drilling holes in bulkheads, pressurized vessel. So what we did is we broke the system into 2 parts in a pressurized aircraft so that just a wire goes from the probes box out in the wing through an existing cannon plug, And then from the existing Canon plug, as a pass-through, it's already there, but it has blank pins on it. It goes into the computer section that drives the displays, that reads the pressure values, that sets up the inputs and outputs for the displays and other things.
At time of installation, are the mechanics that are doing the install, are they programming, or are you guys programming display interface module to the specific aircraft?
That's a good question. Over the years, people have approached us. For example, the PA-46, the Piper Meridian Malibu Mirage MMOPA group, did a lot of flight testing, and their product, we have preset values that when we know a PA-46 is going out, we can load those values into a standard kit, and then it's up to the customer to validate those values, because it's not only the angle of attack, but it's the angle of incidence of the mounting location of the probe and the probe plate underneath the wing. You have to validate that. In most aircraft that don't have a pre-calibrated set of values that we've learned from other customers, like the TBMs, we know what the TBM values are. We actually were the chosen company to retrofit all of the Mitsubishi MU-2 aircraft. They did a lot of test flying, and their units were characterized for flight test values. Most customers, once you get the product in the aircraft, you do 3 simple calibrations in our basic system. 1 on the ground, you zero everything out. So once that's entered, then there's 2 in-flight calibration set points. Think of the display as a ruler or a scale of lift. So you have to stretch or shrink that scale, and you have a set point in the middle, the identifier, which is either in the Falcon displays, all the red and the blue references 1.3 or optimum alpha, or in our most popular unit, which is the Eagle system, it is the donut itself. The full circle, the blue circle, is the 1.3 or optimum alpha value. What we tell people to do is fly an aircraft at stall, simple stall maneuver. When your aircraft brakes, you identify the stall speed for that particular flight one time. It doesn't matter what it is. Whatever it is for that flight, let's just say you take the aircraft up, you fly a nice gentle stall, the wing drops, the nose drops over, and you stalled at 60 knots for this example. You multiply that example, 60 times 1.3, you recover from the stall, that's 78 knots. So you trim for a straight and level flight without climbing or sinking. That's 1.3 stall speed that's correlating whatever the angle of attack is at that 78 knots. That will be a 30% margin away from stall.
Okay. Are you now programming a display interface module on the ground when you kind of get back, or are you doing it all?
No, you're doing it in flight.
Okay.
So when you're flying that value, like say 78 knots, straight and level, you're trimmed for straight and level without climbing or sinking. There's a little calibration module that you enter the value. There's 2 buttons, a cal button and a select button. The cal button is for entering values. The select button allows you to enter the test modes. The second test value that you need to enter is the end of the scale. Where do you want the system to go to the most lift that you have, the lowest angle of attack? We call it cruise value, and that's set at maneuvering speed, weight adjusted. Where do you want the scale to start transitioning? So we selected maneuvering speed, which correlates to an angle of attack. That sets up the end of the scale. So you're in flight, you're flying straight and level at that speed. You push and enter the cal button, enters that value. You have to store the values, and then once you store the values, then you can go in, and if you have the flap I/O module, you can enter up to 3 different flap positions. And then that way with our I/O module, you can take those values and the system automatically selects the scale based on the wing configuration.
Cool.
I get a lot of these questions, which are all good. The problem that general aviation and even in the commercial industry have is that pilots naturally are responsible for the safe maneuvering and control of that aircraft. What angle of attack does is it gives a pilot accurate and responsive information of how much lift that wing is producing. The struggles that I've had over the years was basically convincing a pilot that's been flying for 2 years, 20 years, 50 years, is that when you get in an airplane, airspeed and all those other instruments are valuable added instrumentation that can help a pilot fly safer. Angle of attack is one of those instruments that once you put it in, every single pilot that I've ever talked to says, I don't know why I haven't had this instrument before. This is just amazing. And then I get the naysayers that, well, if you can't fly by the seat of your pants, you shouldn't be in the damn airplane. And then I ask them, how old's your airplane? Do you have a GPS in there? Well, yeah, of course I've got a GPS in there. And I go, well, we're trained as pilots to fly pilotage, right? You fly to and from using charts and maps and times and position.
Understanding the evolution to using more modern technology, use the tools to help you fly safer, more efficiently and effectively around TFRs, et cetera, So to your point, being able to jump between the notion of navigating using current technology versus maps and pencils and E6B calculators versus a new way of flying vis-a-vis fly angle of attack as opposed to airspeeds. Are they making that jump in their mind?
That's a brilliant question, and I'll answer it this way. I've been doing this so long when I talk to pilots and I tell them, if you're going to buy my instrument because it's a cool gauge and I've heard a lot of things about it and I should have it, but I'm going to put it down in my panel, I won't sell it to them. I've had a guy just recently, I refused to sell it to him because he doesn't understand it enough where he thinks that it's just a glorified airspeed indicator. Until they take that leap of faith or that transition to calculating add for this or subtract for that in airspeeds versus an accurate indication of how much lift your wing is producing through angle of attack, once they do that transition or once they listen to what people like me are saying about the success stories of angle of attack, once they do that, you can see their eyes light up. And it's like the pilots that put it in, their feedback to me is instantaneous. One pilot that was a bush pilot said to me, I never knew how close to stall I always was coming into an approach over a lake, or I never realized how much extra lift I had, how far I rolled down the runway because I'm coming in so hot with so much reserve lift that it isn't necessary.
How much time does it take, Mark, for, in an average GA airplane, non-pressurized, to put this puppy in?
We always characterize it this way. We don't quote times on specific aircraft.
Sure.
Because it really depends on how much instrumentation, the model of the aircraft, the year, all that. But typically on a high-wing Cessna, anywhere from 6 to 12 hours, 6 to 10 maybe. I've had people like Liberty University put them in all their 172s and their twin engines in about 4 to 5 hours. In low-wing aircraft, it can be 8 to 10, somewhere in there. Again, though, it could be more, it could be less with the options. If you're adding flaps and gear advisory off of angle of attack, there's obviously additional work that needs to get done. Our kits are different than any of the other products out there. Taking that medical mentality that if it were to fail, it would be an unsuccessful product and the customers you need this instrumentation to be accurate and the performance be there. We include everything in the kit, meaning all the connectors are pre-soldered and heat shrunk and everything in-house. We provide all the wiring, bracketry, hold downs, tubing, fittings. Everything is a system to us. Our kits are a little more money, but the quality of the product is unsurpassed even from some of the bigger companies.
So it is very much a plug and play.
Yeah, all the connectors are all done. The only thing you have to do is mount the product in the aircraft successfully, hook it up to power and grounds, hook it up to the audio panel, and then once that's in there, then the in-flight calibration has to match the aircraft's performance window. And then once that's done, you've got a system that can easily be tested for accuracy every flight or once a year.
So I noticed that we don't have an STC.
The Alpha Systems product line is the first company that's approved under the North Sea State project, or the North Sea FAA project. In 2015, they used our product as the poster child of a product that had a significant safety benefit and qualified under self-certification for 21.8D self-certification.
How does that apply as I'm writing for a Canadian audience? Does Transport Canada have a North Sea approval process, or do they just ride under the FAA's process?
And obviously, you're the expert on Canadian law and your version of the FAA. But I've had customers successfully get it installed through a process that their mechanics take in Canada. We are approved here as a minor alteration. That means no additional FAA certification. It's a logbook entry and a mechanic's signature. In Canada, the process that your mechanics would go through would be hopefully to point out that we are an approved product here in the United States, and they would follow in line with what the FAA's certification and testing forced us to do. But as far as that goes, I don't have a direct answer for you, I guess is the best way to...
How many airplanes do you have installed in Canada?
That's another question I can't answer accurately. I bet you it's under 1,000 maybe.
Cool.
You know, I get a lot of people that say, well, I never fly that close to a stall. Or I was at the Mitsubishi prop seminar here right after Sun and Fun, and I was up there supporting the pilots that are doing proficiency in the Mitsubishi aircraft. I had one gentleman at the end of the show come up to me and say, well, I've got a Husky and I've got a Mitsubishi, and if I follow my numbers, I don't need any other instruments. And I said, you know what, you're right, sir, but having an angle of attack instrument is one of those things that you put in and it shows you exactly what you're doing rather than having to guess what you're doing.
You mentioned that you've got a bunch of I/O modules. You mentioned gear and flap. Are there any other?
Yeah, the add-ons to the standard kit is an I/O module that handles an analog input representation for flap position. We have 4 digital inputs, meaning switches for flaps clean, flaps 10, 20, and 30, or whatever the configuration is, just digital switch inputs. We have gear advisory so that if the gear is not locked down at a certain angle of attack, if you're pulling to a certain angle of attack and your gear is not recognized as being locked in place for landing, it would give you an audio warning such as gear, gear, gear 3 times. There's a stick shaker output now. That the output is there, and we've activated it actually in software, but we haven't come up with a universal stick shaker adapter. We have a heated probe that is available, and what's called a relay kit, so that when you turn on your pitot heat, you don't have to have a separate switch for your AOA heat. It activates the coil of a relay, and the contacts of that relay then are fused and activate the heat for that. One of the things we introduced at Sun and Fun this year is a kit called the Raven kit. The Raven kit was designed for the new aircraft that are coming out with certified AOA systems. And we can read the Air Inc. 429 data bus or the RS-232 data bus, in either case, and mirror through our heads-up Eagle displays, our Chevron displays on top of the glare shield, certified AOA system data, just mirroring the range of AOA from most of the certified systems have an AOA, for example, Garmin displays AOA on their screen. That's great and all. The AOA is there, but it's in the wrong place. And if you add our heads-up adapters for the pilot and or the co-pilot, now you brought certified AOA systems up through a repeater on top of the glare shield, making the usability or the human factor integration of that AOA much, much more important on climb outs and takeoffs and landings.
Keep your eyes out rather than in.
Right. The one thing I'd like to just share with you too is I realize that a lot of people think that you just use angle of attack for approaches and landings to eliminate the base to final stall, the loss of control on that. But with our system being differential pressure, it's measuring the definition of angle of attack is the chord line of the wing, the design of the wing, in reference to relative wind. Normally that's seen as a change of the wing to relative wind that it's flying through. But because we're measuring differential pressure once calibrated, when you're sitting on the end of the runway, you have an instrument that shows the margin of lift from stall. So once you start rolling down the runway and you're building up that lift potential, relative wind is increasing regardless of the attitude of the wing changing on the rollout. So as you get through the red into the blue, once you're into the yellow of our system, that's elevator authority to tell the pilot that you've got a surplus of available lift to be able to pull the yoke or stick back to climb. So now you've got an instrument that you can use full cycle from takeoffs, maneuvering, landing. There's two places that loss of control, if you look at any of the FAA's in the United States here studies, and they just had a commission to outline loss of controls here last week here in the United States. The two highest fatality areas, accelerated stalls on climb outs and loss of control at base to final turn. If we can prevent that by having an ultimate instrument that shows a pilot how much lift margin they have away from stall, if I can save a pilot's life with our instrument, that's really what my goal is to save pilots' lives, to help them fly better.
Any idea how many lives you've saved?
Oh, I'm not that egotistical. I just can tell you that over these years, I've been very fortunate to have people come up and tell me their stories, and one story sticks out. Can I tell you one quick story?
Yeah, absolutely.
I was doing a seminar, I think it was in California. I went to my booth afterwards. You always have a whole bunch of people come up to you and say, what about this and what about that? I remember seeing this lady dragging her husband up to my booth, pushing. She was like parting the wave of people. And she said, tell him what happened to her husband. And he stuck his hand out and he said, I want to shake the hand of the guy that invented something that helped me save my life. And I said, what happened? And he said, well, he's in IMC, it was raining, he was on an approach, everything was going good until he had a bird strike. It took out his prop, the body took out his pitot probe. Fortunately for him, the AOA probe was on the opposite wing. So in that unit, in that day, that was the 4-inch bar graph, or the LED version of it. And so he pitched to the Blue Donut and continued on his glide slope. And fortunately for him, in rain, he's lined up perfectly for the end of the runway. And he did his approach, he touched down just like he should have, and his comment to me was he did a better approach with no instruments, no engine, with just AOA than he had ever done with full engine power and all the other instruments. He said, your system actually helped me save my life. And I've heard hundreds, if not thousands, of those success stories of how it opens up the pilot's eyes and helps everyday flying simpler, saves brake wear, tire wear. It safely allows the pilot to understand how much lift you're actually producing in a 60-degree bank maneuver, base to final turns, climbing out. If you pull too far, you'll be into the red and you're going to start sinking. You pull to the position of what's identified as a stall, and obviously everybody knows what a stall does.
Yeah, and in Canada, historically, our flight training required, including on the flight test, as I'm sure you know, stall spin.
Right. And, you can't enter a spin without stalling a wing.
Which is a lot different than the FAA, which doesn't require on a flight test the student pilot to demonstrate spin and spin recovery.
Right. Here in the United States, when you do the reoccurrence flights, where you go up and you prove to a flight instructor that you can recover from a stall, the turnaround the point, for example, the angle of attack is a way to accurately show lift potential. So if you trim for a straight and level flight and the donut's on, that's a 30% margin. If you keep that donut on, adding or subtracting power, you're just maintaining the absolute margin of lift. If you trim for straight and level and the donut's on and you turn, as long as that donut's on, your lift is identical in any maneuver.
What's on the horizon for you guys?
That's an interesting question. I created that Raven product to take it to the next level. All of our products are being seen as the industry leading because the simplicity, the interface to the pilot, the display, the products itself. I created the Raven, like I said earlier, for a new market, for a retrofit program for commercial, commuter, and transport category product. I don't have a major customer for that product, but it utilizes the displays of our simple systems that big corporate jets still do weight-adjusted approach speeds in every commercial flight. If they just added our AOA, they'd pitch to a known alpha, and then they'd use thrust to increase or decrease their descent rate. It's a transition. And I've been passionate, outspoken person that sees the benefit, has heard the benefit of the use of angle of attack systems. I would like to think that the FAA has seen a benefit here in the United States and across the world. My simplistic approach is that angle of attack will open your eyes up for every pilot, regardless of where you're flying, regardless of whether you were flying an experimental, a warbird, commercial, commuter, GA, certified airplanes. Getting that word out and saving pilots' lives has been a mission for me forever.
Have the flight schools en masse adopted to retrofit their aging fleet of 172s?
Yeah, that's an interesting question, too, because Textron, who is the corporate entity of Cessna, went out for bid here about 3 years ago for an angle of attack system. It was a 5-part program. We were asked to bid along with about 7 other companies. They did not choose our product, but they chose the Safe Flight display, and I found out some other information later as to why they did that, but we were second out of 7 behind Safe Flight. Safe Flight uses a stall tab system that replaces the stall tab, and it measures the angle based on what's called a stagnation point sensor. And it measures the change of alpha based on what angle that stall tab is at, and then it feeds it to the display. Obviously, I believe that differential pressure is a non-movable system. It gives accurate information. We've been tested, differential pressure system, our system, was tested to be within 0.1 degrees of a $40,000 certified boom-mounted AOA test probe. Liberty University is flying our product. I know North Dakota NDSU was looking at upgrading all of their aircraft with angle of attack systems. We had given them a demonstration years ago, but we're the little David in the big gorilla tent, But we strive to make the best product, the most complete product, and God has a path for all of us, sir. So
are you, outside of the shows and the website and all that kind of stuff, are you aggressively marketing out to all the independent flight schools that, with that evangelistic message of change the way you teach folks to fly?
Yes, as a company, we were spending a lot of money in magazines and traveling around. I get asked to speak. Last year I was asked to speak at the TBM convention. They fly me around talking about the importance of angle of attack, not just about Alpha Systems. The approach I take is an understanding of any pilot of the relationship of what angle of attack is versus airspeed is really, really important. And they recognize that. I'm going to be doing more and more informational speeches and conferences and things like that as we go forward. You know, obviously the FAA here has recognized the importance here. I'm hoping that Transport Canada will recognize the work the FAA has seen here in the United States and make it easier. Here's the big problem. In aviation, you can spend millions of dollars on testing and recertification and process and control. If I spent millions of dollars to go through DO 178 here, level A, and DO 160, and all the certifications, you're going to take a $2,000 or $3,000 product and turn it into a $15,000 or $20,000 product. And what the FAA has realized is that there's a certain level of testing and stuff that's required, but to go through all of these steps and all of these performance criterias on a meteor strike with 4 drops of water and blah, 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 and lightning storms and all this stuff, what is your success rate for failure? You're going to take that product and turn it into a $15,000 product. How many pilots do you think are going to buy the product?
Not many.
And you know why? Because pilots are cheap. I mean, pilots, I'm a pilot, I get it. You want the best value to do the most for your dollars.
Yeah, pilots are an interesting bunch of cats, and not to stereotypify pilots, but they'll go to great lengths to save a nickel, but they're okay to spend $250 on a hamburger.
Right, and you know, the problem with that is that, you know, my statement about being pilots cheap, they want the best value. Everybody that I know, everybody that I've talked to over 22 years, they go, you got to show me why I need this in their aircraft. And I'll tell you something, a friend of mine that I've met about 12 years ago is a high-time pilot in Virginia. His name is Fred Scott. He flew out here to meet me to see if I was legit. He said, I lost 3 of my best friends, high-time pilots, to stall spin accidents before they had angle of attack in their aircraft. And he said when he lost his 4th friend to a accelerated stall on a climb out on his private ranch, he said your life will change when you lose your best friend and you have to walk up and down the runway looking for his head. It's kind of a sobering reminder that everybody can benefit from an added instrument, just like a GPS versus a map. It makes flying simpler, safer, and more accurate.
So I think we probably all agree that we want to fly safer, but it seems like it's very challenging to get pilots to start to think about that, make the investment. To your point, if there was perceived value, display technology such as yourself would be standard equipment on all new airframes.
Yeah, they are on the Cessna right now. They're all brand new aircraft coming out, come with that system in it. The FAA here in the United States is recommending that everybody add an angle of attack system to their aircraft. I'm very fortunate to be a part of that. I sat on the steering committee for the adoption of the language with the FAA and other manufacturers around the technologies that were available and possible new technologies coming forward. When I was the first company to be approved, other manufacturers followed step, and now a lot of them, and there's only a handful of us out there now, less than a handful actually, that have a product line. It's one of those things that if I was selling 100 a week of these units, I could even get the price down, but until you get hooked up with a manufacturer like I am with Mitsubishi, when I did the units for Bendix King, when you get the volumes up higher, you can get your prices down lower. I was also asked to review the wording that the FAA put on their website. Because of the way and the approach that I took, it's very valuable that pilots understand this is way more than just selling a product.
Sure.
This is about flying safer using older technology that's been brought up to today's standards.
With you being so close to Duluth, what does Cirrus think about your stuff?
Cirrus actually test flew our product. I've got all the data from them and their test flights, and it was proven accurate within the use of our product in their aircraft. I sell a lot of them into aftermarket, or people buy a brand new Cirrus and they bring it to a shop up in Duluth and they put our product in. The next step would be to approach, for us, a lot of the manufacturers and say, look, we would like to be added to your PMA as a factory authorized product, just like Textron did. That's to be determined, I guess. I guess that's the way I can answer that.
Yeah, it's kind of like, I find another analogy or parallel technology that also saves lives are the carbon monoxide detectors that go in aircraft integrated into the audio panels. And I had the opportunity to interview a Mooney pilot, coincidentally also flying out of Minnesota, that is the poster child for why you want integrated carbon monoxide detectors to give you that early warning. He was able to, and during my interview, as he told me the story, it's like the hair on the back of my neck was standing up. But to make a very long story short, he succumbed to carbon monoxide poisoning on climb out with the autopilot punched in. His Mooney climbed until to about 13,000 feet, leveled out, flew until fuel exhaustion, and then he woke up in a farmer's field.
Wow.
Able to survive the crash with injuries. Obviously, someone was watching over his old shoulder. Now has become an ardent advocate for high-tech carbon monoxide detectors integrated to the aircraft's audio panel, et cetera, et cetera. As listening to you telling the story of Fred Scott, it very much sounded the same.
Yeah, people that I've met, they realize the passion that I have. As a business owner, you always want to believe that your product is the best. And actually, over the years, I've purchased over 250 different angle of attack systems, whether it's an air data computer out of an A4, F-16, Raptor, Airbus. So I have all kinds of different displays and all that. And I utilize the technology that's in that to understand what works from the commercial and military markets to better a product and understand why those systems were so beneficial in those aircraft, and the pilot integration. How do you look at something? How do you read something? And what they saw in those to model our product to be a better and better and better product, to a point now where with the heads up, with the eagle chevron styling or our bar graph, it is just intuitive to the pilot to make it more easy for the pilot to utilize in high alpha situations.
Very cool. So I know I've asked you a lot of questions, Mark. Do you have any questions for me?
Well, what magazine is this going in?
So the Canadian Owners and Pilots Association, fondly known as COPA, has a print magazine called Flight. Goes out monthly to every COPA member, Canadian flight schools, maintenance shops, etc. It's a distribution, I'm told, by COPA, of about roughly 64,000 copies. It's also published online as a digital magazine for download by the membership, and again, coast to coast here in Canada. And usually I take all of my articles and then repost them on LinkedIn.
Okay.
And Facebook.
Do you have an airplane currently?
I do. I own in partnership Commander 114B.
Oh, okay. Your son, is he a pilot also?
He is. He got licensed 3 years ago and has block time on a Cessna 172.
Okay. All right.
Yeah. So it's kind of, in our blood, shall we say. And I, as you could well imagine, was absolutely delighted when my son decided to also get licensed.
Does he have a desire to do commercial flight?
I don't know. He's been in the high-tech industry after graduating university here in Canada and went to work for a Canadian national telecommunication company. After that, went to work for a very large cloud-based software company. And, was trying to decide, as with most young men and women, what to do in life. Yeah.
Oh, yeah. Well,
I might add that you mentioned Transport Canada. They do, on a monthly basis, something called a Transport Canada safety seminar. In Canada, the rules for currency is a little different than the FAA has. You mentioned the requirement for a recurrent flight exam. In Canada, we have many ways to meet the biannual currency requirement. One of them is attending a Transport Canada flight safety seminar. And they're held across the country, run by Transport Canada. And a way to meet the currency requirements, they tend to be very well attended by pilots. They get a sticker signed off by Transport Canada that goes into their logbook to facilitate, currency requirements in the event of a ramp check or anything like that. I would think that, talking about AOA within their program would be a, super awesome way to help educate pilots, aircraft owners to the benefit of AOA technology.
There's a fellow in the United States here that's an ex-military fighter pilot. He's an aeronautical engineer. His name is David Cizo. He works for the FAA, and his mission is because of his involvement with Angle of Attack, and he's actually been given the job training through the FAST seminars, through different organizations where he goes around the country teaching Angle of Attack benefits. Yeah. And we actually donated you might have seen that airplane remote control to the wing system that we have. We donated one of those to the FAA to help facilitate pilots' understanding of what it means to have differential pressure or angle of attack in from the wing to relative winds. So,
very cool. Well, once I'm done my article and it's published, I'd be more than delighted to send it over to you. And I'm told from my friends at COPA that organizations like yourself can stick the article up on your website.
Okay, could you tell me your name again and spell it so that I've got the correct in the magazine that you write for, just so that I have it here on file?
So Phil, Phil, Lightstone, Lightstone, and I write for the Canadian Owners and Pilots Association.
Okay.
And you can find them at www.copanational.org. Kind of think of them as a baby brother to AOPA.
Okay. There is a COPA for the Cirrus Owners and Pilots Association?
Yeah, that's different.
I just wanted to make sure.
Yeah, and that's why, when I mention, why I don't say I'm with COPA, because everyone, when I first started saying that, they got confused with Cirrus and got all excited. But that's why I mentioned that it's the Canadian Owners and Pilots Association, a baby brother to AOPA. As I mentioned, we represent general aviation and really all aspects from GA pilots, commercial pilots flying for, corporate to some degree, as well as, folks that fly Cessna 150s or advanced ultralights or ultralights.
Okay, cool.
Very cool. So check out the website, and Mark, my email address isplight, P-L-I-G-H-T, @rogers.com. And I'll send you a little email, and you'll get my full contact info. And I do really appreciate you taking time out of your day.
Well, thank you. I appreciate it also. And if there's anything else I can do to add to your article, just let me know. We do have pictures and things if you put that.
Oh, yeah, absolutely. So I'll send you a quick note. I've got your business card, and then if you can send me some high-res photos, then we'd be delighted to include them. I think a picture says 1,000 words. Yeah, that would just be really super cool.
Okay. Yeah, I have a graphics artist
Great.
designer in-house, so anything you need, you can get a hold of her. So when I respond back to your email, I'll put her as a carbon copy, and then you can ask her
perfect.
for anything.
Mark, thank you so much, and I do appreciate your time and patience today.
Well, thanks, and I'm sure we'll talk again.